let's do projectile motion first. A student actually asked about the quiz question, so I'm going to do it first. In the quiz question, you had an object that had a speed of 20 meters per second at an angle of 30 degrees. And on these questions, I could ask a number of things. I could ask, what is the total time? I could ask, what is the maximum y height? What is the maximum x range? I could ask, what is the time at the top? Or I could ask, what is the, I could ask, what is the x component of the velocity? I could ask, I could say, what is Vx equal to? I could ask a number of things. And so let's answer each of those questions here. You're going to have this question. You're going to have 5 or 6 projectile motion problems, and one of them will be like this. Actually, I probably have a couple of parts. So this motion looks like this. I have an object that comes up and comes back down, goes up and comes back down again. I know a couple of things about this. I know that the velocity in the y direction starts out big, gets smaller, goes to 0, gets bigger in the negative direction until it returns back to its original value, but in the opposite direction. I also know that the x component of the velocity stays the same throughout the entire trajectory. So if I'm looking at that, where does the object have the smallest speed? Where in this trajectory is its speed the least? The very top, because Vy has gone to 0. The only speed that it has is in the x direction. And the biggest speed is going to be here or here. I know that if I want to find the total time in the air, I know something about this point in space, that Vy is equal to 0. And if Vy is equal to 0, I know that Vy is equal to V0y plus Ayt. That's going to be 0 equals 20 sine of 30 minus 10 times t. And so that's going to be 0 equals to 10 minus 10 t. So the time at the top of the trajectory is 1 second. So if I'm filling in this little table over here, I have 1 second at the top of the trajectory. That means that the total time is going to be 2 seconds, right? Because it's a symmetrical system. It takes the same amount of time to go up as it does down. Now, if I want to know the y position, which is a common question that I ask, I say y is equal to V0y times t plus 1/2 ay t squared. Since I know the time now, this becomes a relatively trivial thing to find. I can find the y position. V0y is equal to 20 sine of 30, or 10, times t at the top of the trajectory is 1 second, minus 5, 1 squared. So that's 10 minus 5, or 5 meters. So the maximum y range is 5 meters. Then if I want to know the x range is equal to Vx times t. That's going to be V cosine theta. That's the x component of V times t, which is going to be 20 cosine 30 times t. I'm going to use 2 seconds here because that's the time over here. And that's the position that I want to know what is the x value of. So what's 20 cosine 30 times 2 gives me 35 meters per second. Or excuse me, 35 meters. So I have x is 35 meters, and then Vx is 20 cosine 30, which is like, what, 17 or so? Yeah, 17, we'll just say 17 meters per second. That's a good problem. I mean, that wouldn't be one problem, right? That would be 1, 2, 3, 4. That would be 5 different problems. You don't have 5 problems all based on that. But you'll have a couple of problems where I ask you individual things about that scenario. Okay? You're also going to have a question. Let's see if I can find one in this exam. That will be like what we did in lab, where you're firing horizontally from a flat surface, from a surface above. Oh yeah, like number 4 here. This, by the way, is fall 2016. And looking at number 4, you're going to have a problem like this. You can bet on it's on the test. So you have a problem like the one we just worked, you're going to have one like this. I have a projectile. It follows a path like this. And I want to know, in this case, what is this distance, x? I could ask you a variety of things about this. I could ask you, how long does it take to go from here down to here? We'll have to find that along the way. I could also ask you, what is the speed of the object down here? We'll work that next, okay? But right now, I want to know, what is x? I know that an object that falls, and an object that follows a path like this, that they'll reach the ground at the same time. Okay? So what I need to do to find the time is to say y is equal to v naught y times t plus 1/2 ay t squared. Basically, I'm just looking at this problem. How long does this take to drop a certain distance? Just like we did in chapter 2. That's going to be minus 45. That's the height. V naught y is 0, thankfully. And so that's equal to minus 10 t squared. So t is the square root of 4.5. I get 2.1 seconds. That's how long it takes to drop that distance. Then if I want to know x, I would say x is equal to vx times t. Vx is 10 meters per second because the velocity in the x direction is in the horizontal direction. Just a second. Oh, go ahead, Lex. Oh, you're right. Yeah, thank you. Good catch. All right. So she said this should be -5. And so this would be the square root of 9, which is 3 seconds. I thought that was strange. I try to limit your calculator use as much as possible. Okay? So yeah, the answer should be 3 seconds for the time. And then Vx is going to be 10 meters per second times 3 seconds, or 30 meters. All right, so D would be the right answer. Another problem that I might, likely, will ask is, what is the velocity at the bottom of the trajectory? So what is the velocity there? I might not ask it in this context, but I'm pretty sure I included a question asking what is the velocity at a particular point. Now you might be inclined to say that it's 10 meters per second. That wouldn't be right. The velocity in the x direction is 10 meters per second. But now I have another velocity vector in the y direction. And I don't know the value for that, but I need to find out. The velocity in the y direction is equal to v naught y, which is 0, plus ayt. That's going to be 0 minus 10 times 3, or minus 30. So I have one vector in the x direction that's 10, another vector that's 30, and I want to know what is this vector. So in order to find the magnitude of that vector, I'll say the square root of 10 squared plus 30 squared, which is the square root of 1,000, whatever that is. Okay? Expect something like that, where I ask you the magnitude of the speed, or rather the speed of the object at a particular point in time or space. And that's what you're going to have to do. You have to find the x component and the y component, and then use the Pythagorean theorem to find the resultant vector. Okay, you can do this, right? You can do it? You can. I know that you can. It is the hardest test of all semester, but you can do well on it. I don't mean to scare you in that, but I want to scare you a little bit. Okay, I have a couple other questions student asked. One, there will be no work on the test. I don't mean that you don't show your work. it's important for you actually to show your work, not for me, but just for yourself. But there'll be no work like physics work. No work equals F times D. So if you see any problems as you're practicing that are about work, then you just disregard those. Somebody asked about V naught Y. When is V naught Y equal to 0? In projectile motion, we have a few different scenarios that you're going to encounter. You'll see this problem. You'll see this problem. And then you'll also see a different problem where it's like it starts at one level and then ends at another level. The only part where V naught Y is equal to 0 is here. It's only 0 there because the motion is all in the horizontal direction. Only when the motion is only horizontal. Okay? And then there's another question here, but let's go into forces, and then I'll address that question. Okay? Any other particular questions about projectile motion? Yeah, V naught Y is 0 when the motion is horizontal, or the velocity is horizontal. That's the word that I'll use, or I'll show you a figure, but I almost always use horizontal. All right. You're going to have some questions like number 11, where I ask you to identify the graph that describes the motion for the projectile. Make sure that you're up on that. Let's do this one. This one is the y component of the velocity that returns to the same position. I know it starts with a big positive velocity. At the top, it goes to 0, and then it continues in the negative direction. Neither of these have 0 on them, so I can just get rid of those. It has to be either A or D. Starts with a big positive velocity, goes to 0, and then it gets bigger in the negative direction. So A would be the right answer. Make sure also that you can do all the others too. Like, for example, if I wanted to know what is Vx versus T, Vx versus T would just look like that, because it has a constant x velocity all throughout the trajectory. If I want to know x versus t, it would look like that, a constant slope in the positive direction as it moves left to right. And then y versus t, this is probably the trickiest, is going to look like this, because it has a big initial positive slope. It has 0 slope at the top, and then it has big negative velocity. By the way, notice that if I'm doing an object that's different, these graphs will look different. So if my object is instead following this path, then the y versus t is now going to look like this. Right? It's just half of that original graph that we drew. Make sure that you can identify those. Don't memorize them. I drew them out here for you, but don't memorize them. Just remember to think about what the slope means. That the slope describes the slope of an x versus t is the velocity, and the slope of a v versus t is the acceleration. That's why this test is so difficult. It's not going to be difficult. Like, if you know what you're doing, nothing's hard if you know what you're doing, right? Well, maybe some things are hard if you know what you're doing. But if you've been practicing, if you got chapters 1 and 2 and 3, then chapter 4 is not going to be that difficult for you. But if you've been struggling through those chapters, then you're probably going to struggle through the exam as well. But you can do well. Absolutely, you can do well on this test. All right. Let's look at number 19. So a block with a mass of 5 kilograms moves on a flat surface. By the way, I'm working different problems in this class than I did in the other class. If you want to go back and watch the video for the other class, that might be helpful for you. But a block with mass 5 kilograms moves on a flat surface. A force of 20 newtons causes the block to move with an acceleration of 2 meters per second squared. Look, if this force of 20 newtons was to act on a 5 kilogram object, it would produce an acceleration of 4 meters per second squared. But I'm only getting 2 meters per second squared. that means I must have some other force. And that force in this case is friction. Always follow the steps. Draw the vectors. Here's my object. I have vectors, I have a normal force. I have a weight. I have a force that's pulling. That's the 20 newtons. And then I also have the frictional force, which is opposing the direction of motion. That's step number 1. I don't need to worry about step number 2, because step number 2 is resolve the vectors onto their axes. I don't need to do that. Step number 3 now is apply Newton's second law. Sum of the forces in the x direction is F minus Fk equals max. Sum of the forces in the y direction are Fn minus Fw equals may. But ay is equal to 0, so this is equal to 0. So I want to know the coefficient of kinetic friction. I'm going to also write up here that Fk is equal to mu k times the normal force. So if I figure out Fk and I figure out Fn, I can find mu. Mu is always the ratio of this force to this force. I have to find Fk. I can do that. I can say Fk is equal to F minus max, which is 20 minus 5 times the acceleration, which is 2. So that's equal to 10 newtons. That is my frictional force, the 10 newtons that's retarding it from going faster. And if I want to find Fn, in this case, Fn is equal to Fw. The normal force won't always equal the weight, but it often does. And in this case, Fw was 50 newtons. I got Fw, I said 5 times 10, m times g, and that gives me the normal force. So mu k is Fk over Fn, or 10 over 50, 1/5 is 0.2. I have a question like that. I'm pretty sure. I don't remember exactly what's on the test. In fact, the test isn't completed yet, but I'm pretty sure I have a question like that on most tests. Oh, we did one like number 20 in class, but as I told you in class, you're gonna have an elevator problem like this. It might not be an elevator, but something that's accelerating up or down. And I'll ask you, this was a little bit different because I asked you for the acceleration, not for the force. Like before we did this problem where I had a weight on a rope and I asked you what was the tension. But this one's a little bit different because I'm asking here for the acceleration. So I have a person in an elevator and they're standing on a scale. This woman has a mass of 70 kilograms. So that means that her weight is 700 newtons. So she has a weight equal to 700 newtons. But the normal force, Fn, is equal to 800 newtons. When you step on a scale, it doesn't measure your weight. It measures the normal force. That you step on a scale and it compresses a spring, and that compression of the spring is the normal force. So it's related to the normal force. Not measuring your weight is measuring the normal force. If you don't believe me, next time you stand on a scale, like push up, right? And that means that your weight is going to decrease. It doesn't mean that your weight is decreased. It's just that the normal force is less. So here, her normal force appears more. Is she going up or down? If she feels heavier, is she going up or down? She's going up. If you go down, it's sort of like you feel lighter, like you can sort of pull it off your feet. So here, I know that she is going upward. So these go away. And I can say the sum of the forces, 800 minus 700, is equal to her mass, which is 70, times her acceleration. So A is equal to 100 divided by 70, which is 1.4 meters per second upward. You're going to have a problem like that. Make sure that you're ready for it. Okay? Okay, let's do number 23, and we'll look at number 24 as well. You'll have problems like both of those. In fact, I think you have about 4 different problems, 4 or 5, that are just on inclined planes. I'll ask you, a series of questions about them. I try not to have them interconnected, but sometimes they are. Like, if you have to find friction, you have to find the normal force first. So if you get the normal force wrong, it means you're going to get your friction wrong. But you're going to have inclined plane problems, so become a master at inclined plane problems. It's a big part of the test. 5 questions out of 28, that's what? That's like 2 letter grades almost if you miss those. So don't miss them, get them right, okay? So 2 kilogram mass is pulled up by a smooth incline. It accelerates. I want to know the tension in the rope. There's no friction on this, but you will see an inclined plane with and without friction. You ready for that? I'm going to draw my forces first. Here's my tension, Ft. I have a normal force that is up. I have a weight that is towards the earth. That's step number 1. Now I'm going to draw my vectors on a coordinate system. I'm going to resolve them. Fn, Ft, and now I resolve my weight. That's Fw cosine of 60. Remember, I'm doing 90 minus 30 to get that angle, and this is Fw sine of 60. Now, I want to know the tension in the rope. I could probably stop right there and say that to find the tension, I have to consider just the forces in the x direction. So I'm going to just do that and say Fw cosine 60 minus Ft is equal to max. And then I look, oh, is the acceleration 0? The acceleration is not 0. Then in fact, my acceleration, that's where you got to be really careful, my acceleration is in that direction. So my acceleration is -1 meter per second squared. Did y'all see that little thing that I did? How the acceleration, which is up the inclined plane, is in the negative x direction. This is our negative x. This is our positive x. So I have Fw, which is 20, cosine of 60 minus Ft is equal to 2, that's the mass, times A, which is -1. And then I solve that for Ft. Okay, if you had gotten the sign wrong, what would you have put? Well, you would have put B. I really should have had 8 newtons here, but just don't get the sign wrong. When I'm talking about the sign, I mean the sign of this acceleration. Make sure you're clear on what is the sign of the acceleration. Very, very important. Okay, let's say, actually, we'll look at another problem and see which one has, let's get one that has friction on it. Oh, here's a good one. We'll come back to inclined planes, but let's do this one, because this is one where the normal force is not equal to the weight. I have a 4 kilogram mass that's pulled across the floor using a rope. I give you the coefficient, I give you the angle, and I give you the tension, and I'm looking for the acceleration. Follow the same 4 steps. Draw the vectors, resolve the vectors. What was number 3? Apply Newton's second law, and then solve those equations. First, draw the vectors. Fn, Fk, Fw, and then I have this extra force out here, F. I'm going to do that on a coordinate system. Okay, so to find the acceleration, I really only need to consider the x motion. But this is complicated because I don't know what Fk is. I have to figure out what Fk is. So my first order will be to say, what is Fk? And I know that Fk is equal to mu times the normal force. So really my first step is to say, what is the normal force? I can do that by looking at the sum of the forces in the y. That's F sine 30 plus Fn minus Fw is equal to 0. Is my normal force here going to be more or less than the weight? Is my normal force more than or less than the weight as I pull upwards on it with this rope? Is the normal force more or less? It's going to be less, right? So my normal force is not going to be 40 newtons. It's going to be something less than 40 newtons. So Fn is equal to Fw minus F sine 30. That's going to be 40 minus 50 times sine of 30, which is a half. So that's equal to 15 newtons. My normal force is 15. That means that my frictional force is 0.5 times 15 newtons, or 7.5 newtons. So now that I have the frictional force, I can find out what is the acceleration. I can say the sum of the forces in the x direction, or F cosine 30, minus Fk equals max. That's going to be 50 cosine 30 minus 15 divided by my mass, which is 4. It's minus 15, yeah. And that's equal to 7.1.
Is that coming from the 50 cosine 30 or the fraction?
That's Fk. So that came about, oh wait, did I do that right? Oh no, I'm sorry. I did that wrong. This should be minus 7.5. That's F cosine 30 minus the frictional force. And that 7.5 was right there.
Okay.
Right, Jahan? Oh, I don't know. What exam is this, y'all?
Fall 2. I'm looking at fall 2017.
For which exam is this? This is fall 16. All right. So it's not going to be 7.1. 15. Goodness, Michael. Minus 7.5. I get 8.9 or 9. I get 9. Is that right? Yeah, B. Okay, that problem had several steps. You had to first find the normal force, which is not equal to the weight. So that's where students usually get tripped up. Once you find the normal force, you find the kinetic frictional force. And then once you find the kinetic frictional force, you can do the sum of the forces in the x direction to get the acceleration in the x direction. Not an easy problem, but you're going to have to do it on Friday or something similar to it. Okay? Just a ball of laughs today, right? Are we doing okay? Feeling okay about this exam? All right. Still got a few days, so make sure that you're practicing. All right. Yeah, this is 17. Somebody asked, how do you know when opposite forces are equal? That is, how do I know when the sum of the forces is equal to 0? The short answer to that is that the sum of the forces is equal to 0 when the acceleration is equal to 0. That means that it's either stationary, a static problem, or moving at a constant velocity. That's what it means to have 0 acceleration. Now, there are some cases that will always have the sum of the forces are 0. And that's always when an object is on a surface. When an object is on a surface, the sum of the forces in the y direction will always equal 0. Because we're assuming that that object doesn't leave that surface. That's true on an inclined plane, too. When your object is on a surface, the sum of the forces in the y direction will always equal 0. Only when it's on a surface and not leaving that surface. Now, we do have some scenarios where the sum of the forces in the y direction is not 0, like with the elevator. When it's moving up and down, those are not a non-zero sum of forces. And in these cases, our x forces can be non-zero too if it's accelerating in one direction or the other. Okay, so phys 17. Look, here's a good example of projectile motion. We did one a lot like this. It just had a different speed. That's what we did at the beginning. So good practice for you to do these problems and make sure that you know how to do them cold. You don't have to think about them. That you're just boom, boom, boom. I know how to do this. You still have to go through the process, but you know how to do it quickly. Likewise, number 6. That's like one that we did. You should know how to do that one cold. Likewise, number 11, like it's which one that we did, that you know how to do that without really any work at all. All right. Did we do incline plane problems yet? Have we done incline planes? Did we do one on the last test? Okay, good. So let's do this one. And then we'll do some actual calculations. You're going to see a problem like 24. I might have done this one in the previous class. I'm not sure. So on these, when you get to a problem like this, you'll see an inclined plane. An important thing to look at is, does it have friction or not? And then also, is it accelerating? And if it's accelerating, what is the direction? And just draw an arrow. This one is accelerating in that direction. And then I'll draw all my forces. I'm going to go and draw my forces. I'm going to resolve them as I'm drawing them. So I know that Fk is up the inclined plane. I know that my Fw is broken into 2 pieces. Fw sine of 30 and Fw cosine of 30. I just skipped step 1. I skipped right ahead to step 2 where I'm resolving my vectors. And then I have Fn. And once I do that, I can think about what my equations are. Actually, I'll just go ahead and write out the equations. Well, now let's look at these 3 options. So first one, Fn minus Fw sine of 60 is equal to 0. That one's not correct. The way that I can make it correct is to make this 30, and then that would be correct. But that is, as it is, not correct. Minus Fk minus Fw cosine 30 equals MAX. You might be inclined to say that one's correct, but it's wrong for one reason, and the reason is that I need to make this positive for that to be a correct equation. And then Fn minus Fw, that's not true. That Fn minus Fw sine of 30 would be equal to 0. Okay? So none of these equations are correct. I recommend that you draw all of your resolved vectors, and then once you do that, if you want to take the extra step, you can actually write out the sum of the forces. In the y, that would be Fn minus Fw sine 30. That's equal to 0. And sum of forces in the x is going to be Fw cosine 30 minus Fk equals to 0. Or not equal to 0, equal to MAX. And then you can compare them to the equations that are already there. You probably don't need to take that step. Probably you can just draw your resolved vectors. Alrighty? Yeah, Lex? Okay.
Where you wrote Fn minus Fw sine 30 equals 0,
Mm-hmm.
wouldn't that mean that they're equal because if you added over.
They are equal. Yeah, you're right. And so, in fact, sometimes I'll write in this list of equations, if I write Fn equals Fw sine 30, then that would be an equation that I would write, and that would be correct. Is that the question is that all of your question? I sort of cut you off.
Like I thought that when there's no acceleration, that they're equal. But this one says it is accelerating.
But it's not accelerating in the y direction. It's only accelerating in the x direction. And so that's why I have ax equal to 0, or ay equal to 0 here. That's what that means, is that ay is equal to 0, and that's why the sum of those forces is 0. You have to ask yourself the question of, is it accelerating in the x or y direction? In this case, it's not accelerating in the y direction, but it is accelerating in the x direction. That's a great, great question. Okay? Did I answer it completely? Okay, good. All right, let's do, we have about 30 minutes left, right? It never gets old, that joke, does it? I did this problem, so let's go to another exam. We're gonna, wait, no, I did this exam. Oh, we'll go back. Fall 17. I think I did one. I think I did this one. We'll just do it anyway. All right, so the block has a mass of 1 kilogram, and it sits on an inclined plane, and I want to know what is the acceleration of the block down the inclined plane. By this point, you should just be able to draw your resolve vectors. So I'm going to skip step 1. If that bugs you, just go with step 1. So I have Fn. I have no friction, so really all I have is Fw. So this is Fw sine of 60 and Fw cosine of 60. And I want to know what is the acceleration down the inclined plane. I only have one force acting along the plane. So this is just going to be the sum of the forces in the x direction is equal to Fw cosine 60. Actually, if I want to be accurate about it, I need a negative here because it's actually going in the negative x direction, is equal to max. And then I solve that for ax. That's going to be 10 cosine 60 divided by 1 kilogram. That's going to equal to 5. So 5 meters per second squared. I didn't have a negative. Really, the correct answer would be negative 5 meters per second squared, or 5 meters per second squared down the inclined plane. Yeah. Oh, the 10 is Fw. So the mass here is 1 kilogram. So Fw is 10 newtons. 1 times g, which is 10 meters per second squared. So I get a weight of 10 newtons. Okay, so that was really just a setup for the next problem, where if the coefficient of kinetic friction is 0.12 newtons, if it's 0.12 newton, if mu k is equal to 0.12, now what is the acceleration? So now I'm going to add a vector here that is fk. And I need to figure out first what is fk. In order to do that, I have to figure out what is Fn. But I know that Fn is equal to Fw sine of 60. And that's equal to 10 sine 60, or 8.7. And then, if I want to know Fk, I know that's mu times the normal force, which is 0.12 times 8.7, and that's equal to 1 newton. So now, to find the acceleration, I do exactly what I did before, but I'm just going to do it, add in that frictional force. The sum of the forces in the x direction is equal to Fk minus Fw cosine 60. That's equal to max. And so that's going to be 1 minus 5 is equal to 1 kilogram. This is 1 Newton. That's my frictional force times the acceleration in the x direction. So AX is equal to -4. It goes slower. It has a slower acceleration now because it has this frictional force acting upon it as it moves down the inclined plane. Okay? Are you going to see an inclined plane problem? Yes. Liz, you go by Liz? Possibly. Yeah, I think, I don't know. I think maybe so. Yeah. I will tell you that it'll be symmetrical if you have one like that. I don't have these on every test, but you could see it. Like this one, right? Yeah. We did this one in class, and so I'm going to go ahead and assert that the two tensions are identical because it's symmetrical. And if you encounter this question, I actually think it is on the test. I'm not sure. I think it is. If you encounter it, then just go ahead and say, well, those two tensions are the same. So I have 3 forces. I have this tension, I'll just call those FT. And you remember when we did the sum of the forces in the x direction, that we had FTL cosine 60, FTL, or FTR cosine 60, that those were equal to one another. So we said, oh, well, FTL is the same as FTR. So we're not going to designate left or right, just because we already know that. And then this is the weight. And then I can resolve them. I have 2 FT, this angle is 60 degrees, sine of 60, and FW, and here I have FT cosine of 60, and FT cosine of 60. So if I want to know FT, I'm going to look in the y direction. This is the sum of the forces in the y direction. Since it's not accelerating, are going to be 0. So I say 2 FT sine of 60 is equal to FW, or rather minus FW equals 0. But that means that it's equal. And then solve for FT. FW is 220 newtons. I got that because this is 22 kilograms. I multiply it by 10, divided by 2 sine 60. That's 127, 130. So the force in one of them is going to be 130 newtons. Yeah, Jahan? It's what? Okay, can you just read it to me? Yeah, that's a good question. So this object has an initial speed of 45 meters per second, but somewhere along the way, it hits something right here, and that occurs at t equals 2 seconds. We did a problem that was similar to this in the beginning, right? With I think it was horizontal too. What you have to figure out is what this velocity is. This velocity is 45. What you need to know is what is this velocity? The velocity in the y direction, and that velocity is going to be v naught y, which is 0, plus ayt. So that's going to be 0 minus 10 times t, which is 2 seconds. So my Vy is going to be equal to negative 20. Then realize I have a vector that's 45 units, and then a vector that's 20 units, meters per second, and I want to know what is that vector. So that's going to be the square root of 45 squared plus 20 squared, which would be, this is on your quiz, $49. All right. Good question. Probably going to have it on Friday. Now we have forces and projectile motion. So I can ask you like every question conceivable. So really, I think almost every question we've done today on the test, on the test, on the test. Emily?
I have two questions about the previous two we had to 2017.
Okay. What is this?
25 and 26.
This one.
So I missed it. So for the first one, are you putting a negative sign on the 5? Or
Yeah, that I said that really the acceleration, which is down the inclined plane, that's technically in the negative x direction. But none of them had negatives, so
it should be negative 5.
Sort of, I guess, yeah.
And then for 26, is it D? Even though it's negative?
Yeah, it would be D. Mm-hmm.
Okay.
All right. Okay, any other specific questions about the exam, just what to expect? Logistics of the exam, unrespond us, you can come in this room as well, but only if I email you. All right. If I don't email you and you still want to come, you can come and see if there's space, but I'm going to reserve those spaces for those students that have already told me they're coming. Yeah? No? All right. I might be a little bit nervous. It's sort of hard to tell what your faces look like. Like if you're scared or you're like, I got this, but I'll be around. We have a help session tomorrow at 1 in 165 across the way. But let me know. I'm here. Okay? You have a good day.